Kia ora koutou. This is the first video that goes with the classwork today. So I'm just going to slowly work through all of these questions. And I'm starting with 3 questions that are achieved questions. So let's have a look at them. The first one gives us 2 complex numbers. We've got z is equal to 4 plus 2i, and we've got w equals negative 1 plus 3i. So there are 2 ways to do this question. We have to find the arg of zw. Hopefully you'll remember that the arg of 2 complex numbers multiplied together is just the sum of the separate arguments. But to work with this, we need to know what the individual args is. Now in this case, this turns out to be a pretty inefficient way to do this question, but I'm going to show you how we do it that way anyway. So we can take z and just whack it roughly onto an argon diagram. And we can see we're in the first quadrant. So the argument of z is tan inverse of the y component, 2 over 4. And that is not a particularly nice angle. It turns out to be 26.6 degrees. And the arg of w is equal to tan inverse. So w is up here, so negative 1 plus 3, so it's up here. So the arg is around here. So it's tan inverse of 3 over negative 1, but we have to adjust it by adding on 180 degrees. So guys, I'm partly doing it this way just so that you get practice at doing these skills, even though this is not how I would answer this question, right? So the 2 separate arguments are that, and that means that arg of zw is those 2 added together, 26.6 degrees plus 107.2 degrees, which equals 135 degrees. And that's a totally fine way to answer that question. But because in this case we've just got 2 really simple complex numbers, we are just going to multiply them together and then find the argument of zw directly. So w is equal to 4 plus 2i, and z is equal to negative 1 plus 3i. That gives me wz is equal to 4 plus 2i times negative 1 plus 3i. Multiplying those out gives me negative 4 minus 2i plus 12i minus 6, which is negative 10 plus 10i. And you'll see straight away that that's a nice complex number. And so we can put that, just put a dot out here, negative 10 plus 10i, and we can see straight away that the argument of that, because these are equal, is going to be 135 degrees, or if you're working in radians, 3 pi on 4. Okay, so that's the first question. And just to be really clear, if I had been doing this in the exam, this is the method that I would have used. Right, the next question is a very fast one. It's using the remainder theorem. So what is the remainder when this polynomial is divided by x plus 3? So x plus 3 equals 0 means that the root would be at x equals negative 3. So we take x equals negative 3 and we sub it into here. So p of negative 3, p meaning polynomial, gives me 2 times negative 3 cubed plus negative 3 squared minus 5 times negative 3 plus 7. And when you work all of that out, what do we get? We get negative 54 plus 9 plus 15 plus 7, which gives me negative 23. And just one more question before I run away to staff briefing. This is a complex number, and this can be expressed in this form where k is a real number. So what I'm going to do here is multiply the top and bottom by the conjugate of 5 plus I. If you're having trouble with any of these questions and you're working from home, the old Delta has these questions in chapter 7. So it's not right next to the chapter with all the stuff on loci, just in case you were wondering. Right, now where's that complex number gone? I've lost it. Okay, 2 plus 3i over, what is it, 5 plus I. 2 plus 3i over 5 plus I times it by, timesing it by 5 minus I over 5 minus I. Always start with your denominator, and there we're going to get 25 plus 1, so 26. And up here we get 10 plus 15i 10 plus 15i minus 2i plus 3, giving me 13 plus 13i over 26, which is equal to 1/2 times 1 plus I, which is the form in which it was requested. So k is equal to 1/2. So there you go. I'll try and get the rest of the questions YouTube during the day, but it'll probably be later on this afternoon. If you have got any specific questions, I should have a bit of email time though, so just drop me a note and I can probably point you to the best place in the textbook for some more practice on those ones. Thanks for watching.